C# has following different types of operators. 1. Assignment operator equals int x equals 10. 2. Arithmetic operators plus, dash, slash, asterisk, %. Any mathematic operation using the 5.3. Comparison operators equals. 4. Conditional operators end. 5. Ternary operator, x data type VariableName equals condition. Value 1, value 2. 6. Null coalescing operator. 7. Bitwise operator in C#. There are 5 bitwise operators which work at bit level or used to perform bit-by-bit operations. Following are the bitwise operators. Bitwise AND takes 2 numbers as operands and does AND on every bit of 2 numbers. The result of AND is 1 only if both bits are 1. Bitwise OR takes 2 numbers as operands and does OR on every bit of 2 numbers. The result of OR is 1 any of the 2 bits is 1. Bitwise XOR takes 2 numbers as operands and does XOR on every bit of 2 numbers. The result of XOR is 1 if the 2 bits are different. Left shift takes 2 numbers. Left shifts the bits of the first operand. The second operand decides the number of places to shift. Right shift takes 2 numbers. Right shifts the bits of the first operand. The second operand decides the number of places to shift. Unary operator. Operator that takes 1 operand to perform the operation. EX++, dash, right to left. Binary operator. Operator that takes 2 operands to perform the operation. Ternary operator. Operator that takes 3 operands to perform the operation. Default value of reference type is null and value type is some form of 0. Nullable type. A nullable type can represent the correct range of values for its underlying value type, plus an additional null value. For example, nullable int can be assigned any value from -21474836648 to 21474836647, or a null 8 to 21474836647, or a null value. Syntax: nullable int I equals null, or int I equals null. The nullable type allows you to assign a null value to a variable. Nullable types can only work with value type, not with reference type, because it already contains a null value. You should use getValue or default method to fetch the value as .value, and direct accessing values may fail in case of null value.x1. Nullable types are useful in forms where you need a value from user. Example: bool type field graduate, which can have yes or no. If someone skips the field, then we should be able to store it as no value, which is not possible in case of bool type. So if we use null for default, then we will have a condition where value is null to represent value not entered. X2, database. In database, there is no value type and reference type, so it will return null value. So reading from DB can be stored in nullable type. You can use nullable.hasValue and nullable.value to check the value. If the object assigned with a value, then it will return true, and if the object is assigned to null, then it will return false. If the object is not assigned with any value, then it will give compile time error. The main use of nullable type is in database applications. Suppose in a table a column required null values, then you can use nullable type to enter null values. Nullable type is also useful to represent undefined value. You can also use nullable type instead of reference type to store a null value. Output -0, 0, 47. Escape sequence. In C# there are few characters, or sequences, which interprets different notation to compiler. So in order to use those characters or sequence we follow an escape sequence, which in C# is a \, which will inform compiler to treat them as literals. Nulculation is an important operator in C#. As per the MSDN definition, the operator is called the null coalescing operator, and is used to define a default value for nullable value types or reference types. It returns the left-hand operand if the operand is not null, Otherwise, it returns the right operand. The C# Null Coalescing operator is a binary operator that simplifies checking for null values. It is used to assign a default value to a variable when the value is null. Say if a value is null, you want to add some other value, you can mention that value on right-hand side. So it will take that value if the literal's value is null.x. Available in C# 8.0 and later, the null coalescing assignment operator equals assigns the value of its right-hand operand to its left-hand operand only if the left-hand operand evaluates to null. The equals operator doesn't evaluate its right-hand operand if the left-hand operand evaluates to non-null. We have two types of conversions. First, using typecast operator using int x equals int float value. This will work even if float value overflows and x will store some value without throwing any exception, which is not reliable. Second, using system.convert. If this is used, then an exception will be thrown if there is overflow when converting. If the number is in string format, you have two options. 1. Parse, and 2. Try parse. Parse method throws an exception if it cannot convert the value, whereas tryparse returns bool if it can be converted. And one of the overloads can be used to store the parsed value in case if the conversion can happen. String x equals 20. Int y equals 0, bool is converted equals int.tryparse, x, out y. This will store the parsed value in y in case of successful conversion. An array represents a fixed number of variables, called elements, of a particular type. The elements in an array are always stored in a contiguous block of memory, providing highly efficient access. An array is denoted with square brackets after the element type. Disadvantage of arrays is, it cannot grow in size once initialized. For example, char, vowels equals new char, 5, / declare an array of 5 characters. Square brackets also index the array, accessing a particular element by position. Vowels, 0, equals a, vowels, 1, equals e, vowels, 2, equals I, vowels, 3, equals o, vowels, 4, equals u. Console.writeLine, vowels, 1. / a char, vowels equals new char, a e I o u, char, vowels equals, a e I o u. An array itself is always a reference type object, regardless of the element type. For instance, the following is legal. Int a equals null. Indices let you refer to elements relative to the end of an array, with the caret operator. Caret 1 refers to the last element, caret 2 refers to the second to last element, and so on. Char, vowels equals new char, a e I o u, char last element equals vowels, caret 1, / u char second to last equals vowels, caret 2, / o, caret 0 equals the length of the array, so vowels, caret 0, generates an error. C# implements indices with the help of the index type, so you can also do the following. Index first equals 0, index last equals caret 1, char first element equals vowels, first, / a char last element equals vowels, last, / u ranges. Ranges let you slice an array by using the operator. Char, first 2 equals vowels, 2, / a e. Char, last 3 equals vowels, 2, / I o u. Char, middle 1 equals vowels, 2, 3, / I. The second number in the range is exclusive, so 2 returns the elements before vowels 2. You can also use the caret symbol in ranges. The following returns the last 2 characters. Char, last 2 equals vowels, caret 2, / ou. C# implements ranges with the help of the range type, so you can also do the following. Range first 2 range equals 0, 2. Char, first 2 equals vowels, first 2 range, / a e. Once an array has been created, its length cannot be changed. The system.collection namespace and subnamespaces provide higher-level data structures, such as dynamically sized arrays and dictionaries. Array is reference type. Hence, when array is passed by value, It will work as if passed by reference. Multidimensional arrays come in two varieties, rectangular and jagged. Rectangular arrays represent an n-dimensional block of memory. C# supports multidimensional arrays up to 32 dimensions, and jagged arrays are arrays of arrays. Array.rank property is used to get the rank of the array. Rank is the number of dimensions of an array. Rectangular arrays are declared using commas to separate each dimension. The following declares a rectangular two-dimensional array, where the dimensions are 3 by 3, int, comma, matrix equals new int, 3, 3. The getLength method of an array returns the length for a given dimension, starting at 0, 4, int I equals 0, int, array sd equals new int 2. Int, array, int, array, int, int, Once an array has been created, multidimensional arrays come in two varieties, rectangular and jagged. Rectangular arrays represent an n-dimensional block of memory. C# supports multidimensional arrays up to 32 dimensions, and jagged arrays are arrays of arrays. Array.rank property is used to get the rank of the array. Rank is the number of dimensions of an array. Rectangular arrays are declared using commas to separate each dimension. The following declares a rectangular two-dimensional array, where the dimensions are 3 by 3, int, comma, matrix equals new int, 3, 3. The getLength method of an array returns the length for a given dimension, starting at 0, 4, int I equals 0, I matrix.getLength, 0, I plus 4, int j equals 0, j matrix. GetLength, 1, j plus matrix, I j equals